Good morning, respected dignitaries, organizers, and participants. I am Neelam Singh, Assistant Professor, Department of Computer Application, Graphic Era, Dean to be University. I welcome all the participants to this 3 days workshop. I will be covering in my session some of the very interesting facts about cloud computing, like an introduction to cloud computing, the major players in the arena of cloud computing, and the backbone behind cloud computing, that is virtualization. The agenda for today's session will be what is cloud computing, the different perspectives behind cloud computing, the properties and characteristics which cloud computing exhibits, and the benefits from cloud computing. We will also explore the various service and deployment models in relation to cloud computing. So I want to start with a quote from John McCarthy, which says, computation may someday be organized as a public utility. Interesting. Can you imagine if we talk about computation as a utility, say 20 years or 30 years back, possibly it was a dream. Reason being, what is a utility? First of all, we want to know. A utility can be defined as something which can be delivered or which can be provided to the end user in the form of a requirement, a necessity, and which can be charged for. For example, if we talk about electricity grid, I think you all know what is an electricity grid. So how you get power supply? You get power supply using a meter which is there in your home or which is there in your organization. Based on your requirements, you've been charged. How much electricity you use, you've been charged according to that. So, can you imagine? In 1961, John McCarthy has thought of computation. In the very same way we get utilities, he thought that computation can also be delivered in the very same way. So let's see how this thing has been made possible by cloud computing. So first of all, we should know what is cloud computing and what are the opinion or perspectives of different organizations. Now to start with, this is one of the most important definition, a benchmark for cloud, and this definition is given by NIST, National Institute of Standards and Technology, Technology Administration, US Department of Commerce. And according to this definition, we can define cloud computing as a model for enabling convenient on-demand network access to a shared pool of configurable computing resources, example networks, servers, storage, applications and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Now, what this definition actually tells, according to this, we can access a network as per our requirement. On demand means I need it, I can access it. And we can access a shared pool of computing resources. And what are computing resources? These can be networks, servers, storage, software, or services. And these resources can be provisioned, can be provided, can be given on a pay-per-use basis and released with minimum effort or with minimum interaction from the service provider. Means we do not have to ask the service provider to grant us the resource, and when we don't need it we have to give him the message, yes, we don't need it, please release it. So we require a very minimal interaction with the service provider, and with the help of this model we can or this model actually promotes availability, and it comprises of 5 essential characteristics of cloud along with 3 service models and 4 deployment models. Now what does Wikipedia says? Cloud computing is internet based computing, means computing which can be done with the help of internet. whereby shared resources. Again, you will find this common term whereby shared resources, software, and information are provided to computers and other devices on demand, like the electricity grid. The same way we access electricity or power supply in our home, in the very same way, cloud computing can be used. And it is a style of computing in which dynamically scalable and often virtualized resources are provided as service over the internet. So, with the help of internet, we can access resources which are usually virtualized and which are dynamically scalable. Scalable means the number of the resources according to requirement can be increased or decreased. We'll see what exactly how this works. According to Waters.com, the name cloud computing was inspired by the cloud symbol that's often used to represent the internet in flowcharts and diagrams. Cloud computing is a general term for anything that involves delivering hosted services over the internet. Means I already have something which is available on internet which is being hosted. Hosted means we have a server which provides us this service. According to Guya, a cloud is a type of parallel and distributed system which consists of a collection of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources based on service level agreements established through negotiation between the service provider and the consumer. Now, you will find that there are some of the terms which are commonly being used by all the organization or people when talking about cloud. This is parallel and distributed system, virtualized computers, dynamically provisioned systems, and these are actually related to the cloud. And then we have service level agreements. What are service level agreements? Although we will discuss them in detail, but talking about service level agreements, for example, you download some software into your mobile or onto your system. At the end of that, you will find it says accept terms and conditions, or it says read the terms and conditions and click on or select accept. Now what do, you either read or you don't read. Many a times you just skip all this thing, you just click on I accept the terms and conditions and then you click OK or submit. So those terms and conditions are service level agreements, which tells that yes, this software is going to collect this much amount of data. This software will be stored like this. This software can be used in this way. So these are the service level agreements between the user and the provider. So let us explore some of the properties of cloud computing. Now, what are the properties? Now, because it is a paradigm of computing, it gives a new way as to how we will think what IT industry is and how it can work. And it is not focused on any specific technology. Now, the central ideas behind cloud computing is utility computing, service oriented architecture, and service level agreement. Now, what is utility computing? It means computing in the form of a utility. Means we can provide computing resources as we provide any of the utility to a consumer. For example, electricity, water. In the very same way, computing can be provided. Means you will pay or you will be billed according to the amount you are using. Just like you use your electricity, suppose you are using 100 kilowatts in a month, so you will be charged accordingly. In another month, you had used only 50 kilowatts, so you've been charged based on 50 kilowatt. So this is what utility says, that the amount you are using or the resource which you are accessing, it will be charged according to your usage. Then is service oriented architecture. Service oriented architecture basically focuses to provision every resource in the form of a service. For example, you want that I do not want to store all the content in my machine. You want that you've been provided a given GB of space on cloud. So what you are taking actually, you are taking a storage as a service from the cloud. Or you want to access a database management system or an RDBMS which is not there in your system and you do not want to install it. So what you are doing, you are accessing a service which is database as a service. So in service oriented architecture, everything is treated as a service. Then we have service level agreements. And what does this service level agreement says? It provides the terms and conditions to use that service. For example, the billing cycle, the amount you've been provided for, the usage pattern. This is all what service level agreement tells you. Now, these three things actually focuses on some of the major characteristics and properties of cloud computing, which are high scalability and elasticity, availability and reliability, manageability and interoperability, accessibility and portability, performance and optimization. These are the characteristics or properties which these three concepts provide. And how this is being provided, there are some of the enabling technologies, techniques, which helps to provide these properties or characteristics associated with cloud computing. This is hardware virtualization, parallelized and distributed computing, and the use of web services. So let us explore these properties and characteristics one by one. These are the properties like scalability and elasticity. We have availability and reliability, performance and optimization, accessibility and portability, manageability and interoperability. So talking about the main theme behind these three uh, or the central idea behind these three concepts: utility, computing, service oriented architecture and service level agreement. Now if I'll ask you, before using Microsoft Office, you first tell me what the code behind Microsoft Office is, or how the thing has been done, how you open a file, how the file is being searched, and then it can be opened using MS Office or using Microsoft Word. Do you actually care about that? No, you don't know what is the code behind that. Although as a software developer, yes, you've been curious or you probably have an idea, yes, this type of code can be used and this is how it can be accessed. But as a normal user, I don't actually care about how the work's been done. I'm only concerned about what I will get. Yes, if I am purchasing Microsoft Office, I'll be getting Microsoft Word, I will be getting a presentation software, I'll be getting a spreadsheet software. This is what I am only concerned about. Then I also am not bothered about how Microsoft is actually doing this, how it is incorporating all the softwares in one package or one suite, which is called Microsoft Office. What I am concerned about is the quality of service. If I am using Microsoft Word, do it will be helpful in performing all the tasks which I want or which it is intended to? Is the after service is proper, suitable to me or not? So I'm only concerned about the quality of service, not how they are actually doing them. And then, for example, you buy a SIM of let's say it's Jio. Now, how these mobile phones or SIM cards work? You need a tower within a given range so that you can access the signals. So, do you purchase a tower when you purchase a Jio SIM or when you purchase a mobile SIM? I don't think so. No one do, because a mobile tower is being accessible to number of thousands of users who are in that area. It could be anyone. So, do you actually own the physical infrastructure? No. You what you do? You only pay for the SIM, and accordingly you will be charged. So, when you talk about a user, there are three things which the user wants: what they are getting, the quality of the service, and how much they have to pay what they are using. So these are only the three things which a user actually care about. And what actually user thinks of? The service. Do they get the proper service? For example, if Geo is not working properly, you will probably be thinking of porting your number to some other service provider. So what you are actually concerning about, whether you are getting proper services or not. So as a user, we have only this thing in mind. Now comes utility computing, one service provisioning model. So what this means, the service provider makes computing resources and infrastructure management available to the customer as needed. Means I actually don't know where the tower is, how the tower is working. I only know that I am getting the resources according to my requirement. I am getting an internet pack, I am getting a calling facility so that I can use that. Similarly, if we talk about this thing in terms of cloud computing, cloud means I'll be given a range of resources starting from infrastructure to software. So I can access any of these resources in the form of a utility as a service, and I've been charged for a specific usage rather than flat rate. Means I do not being charged like as you are using a storage. You will be charged say 20 rupees per GB. No, this is not the rate. The rate will be according to the time and according to the amount which you want to use. So it is not a flat rate. It will be according to your usage. I don't want 1 GB. I want 1.5 MB. I want 256 MB. So I've been charged accordingly. Like other types of on-demand computing, the utility model seeks to maximize the efficient use of resources. Means I can use the resources because I have the requirement of those resources. If some resource is not in demand, I can remove it or I can say deprovision it. So this is how on-demand computing works. The more the demand is, the maximum the utilization is. Now, what is a service? When you talk about a service, it can be connected together using web services. It is the endpoint of a connection. Now, in totality, if we talk about a service, it needs to be well defined, it needs to be self-contained, and it should not depend on the context or state of the other services. Now, again, if we talk about service in terms of cloud computing, for example, I want to use, let's say, Anaconda. It's a IDE which is used to develop Python programs. It can give you say tools related to visualization. It gives you tools related to R. So I want to use it. Now I don't want to download it. So what is my services? My service is that I can access Anaconda. So it is a well-defined set of service what I want to use with the help of Anaconda. I know I'm using Anaconda for these all purposes. A service should be self-contained. Now, if I'll say I am accessing Anaconda, but before accessing that, I need to download something else in my system. Let's suppose I am accessing it using cloud, but my cloud vendor says no, you cannot access Anaconda if you do not have Python in your machine or if you do not have RStudio in your machine. That will or that doesn't solve the purpose of a service. It needs to be self-contained. Means I do not have to install some other things in order to use a service. It should be self-contained. And also it does not depend on other services. Like already I have Python in my system. It is not compulsory that if Python is not working, Anaconda will not work, which I am using through cloud. Why I am accessing Anaconda? Because I do not want to use it on my machine. I do not want to install it on my machine. So that is what the context means. I am using Anaconda because it is there on cloud. I want to access it and I do not want to take into consideration what other services are or how they are working. I am only concerned or bothered about what I am accessing. That is what a service is. Now, what is a web service? Now, if we talk about a web service, it is a self-describing and stateless module which can perform discrete units of work and are available over the internet. For example, there can be different type of operations which can be performed using web services. Like you can send a one-way message, you can request a response, you can solicit a response, or you can give notification to multiple receivers. Let's say I am working on uh, for example, if I am working on a registration page and I'm say putting up some values in my registration page, this says enter your name, enter your email ID, enter your username, enter your password, and so on. You would have seen whenever you are putting up some values, it gives you some error message also if the values are incorrect. So that is a kind of request response mechanism. I'm requesting something that I want to register these values. It should be stored in a database, right? But what is going on? I am also getting a response whether the data which I am putting in my page is correct or not. So this is how a web service works. It gives you response. Or for example, you go to a web page and you want to download something. So what web service is doing? It says thank you for downloading. Your download will start in a few minutes. So it is only giving you a message, yes, yes, you had requested for a download, so it will start after some time. So when you are using a web service, it gives you these type of options so that you can work in discrete form, and these are available through network. Now what is service oriented architecture? Service oriented architecture means a collection of services which can communicate with each other. Now, it is not compulsory that they need to be they need to be in a communicative mode all the time, but yes, they can communicate with each other. They contain a flexible set of design principles which are used during the phases of system development and integration. Now, when we are working with services, or when we are using service oriented architecture, there are a set of design principles which needs to be followed. But services can be of any type, of any nature, so it needs to be flexible so that they can be integrated properly in a system during the development time, and they can then be maintained accordingly. And these services should be loosely coupled. Loosely coupled means it should not be the way that if I had created two services, a state of a service can affect the state of the service of another. Let's say in my system I have two services, A and B. If I am working on service A, then service B should not be affected. They should be two different services. Yes, they can communicate, but their states will not actually hamper the states of each other. So they provide, or service oriented architecture provide, a loosely integrated suite of services that can be used within multiple business domains. And they are implemented as web service model, as we can see in the diagram, that service provider will get a service request from the consumer, and accordingly the provider will give a response. For example, whether the service can be allotted or not, or whether how much time has been left after which the service can be deprovisioned. These all request response mechanism can be used. Then quality of service, yes, it is a major point, and these are the set of technology so that network traffic can be managed in a cost effective manner, and it can improve user experience. And there are two factors behind this. One is customer care evaluation and another is technological evaluations. Now, what is customer care evaluation? In terms of issues, I am a customer. You had seen there is an ad. Uh, I don't remember. It's of Airtel, I think, which says after some time we do not have any queries. It says zero queries. So that is what the quality of service we need. That as a vendor, there should not be any query with respect to the consumer. He will get the maximum what he wants. So, because it can directly impact the customer, and it can have a negative impact on the goods and the services. So, it is one of the important factor, how customer evaluates what are his queries, what are his issues which needs to be evaluated. And in terms of technology, means let's say we started with 2G, then we converted to 3G, now we are using a 5G testing also. So what is this? This is technological innovations, and these are required so that you can meet the customer demands. So quality of service has to do with the efficient operations of various systems. And this is dependent on adjusting our procedures, adapting to new software programs, new code, and we have to improve our technological base so that we can give maximum quality to the end user. Then we have service level agreement, and as we had discussed, this is a contract between a provider and a customer, which defines in measurable terms. Means you can actually calculate, you can actually quantify what services the network provider will furnish or will provide. And the common things which are being done using service level agreements are performance and their matrices. What will be the up and downtime ratio? Means at up to how much time the service will be available. Is it 24 hours, or is it less than 24 hours, 100%, or it is less than that? The system throughput, the response time, how the problem will be managed, how the what will be the penalty if there is not if the application or the service is not performing. Are any do there exist some documented security capabilities or not? So this is what service level agreements define. Now this is one of the very important feature when we discuss cloud computing: scalability and elasticity. To be a very layman term, how we will define scalability? It is the measure of handling growing workloads in a graceful manner. Or it can be defined as a capability of a system to increase its ability according to the requirement. And how ability can be increased? By increasing the number of machines, by increasing the network size or a process, so that it can handle the requirements accordingly. And what is elasticity? The ability to apply a quantifiable methodology. Quantifiable means you can actually calculate how much a system can be, how much the system is flexible, how can the capabilities be increased. And these properties are achieved by two ways. One is dynamic provisioning, and second is multi-tenant design. Now, what is dynamic provisioning? If we talk about provisioning, it means to provide a resource to the user. Now, what is dynamic provisioning? For example, uh, you would have seen that during New Year or during Diwali, it takes a network to send message. Means whenever you are sending some messages, a good or a wish message to your friends, to your relatives, it takes more time as compared to normal days. Why is it so? Because at that time, the requirement or the usage is at its peak. So, when we talk about any computing environment, dynamic provisioning means during the requirement. Means if the requirement says that yes, I need more of the network bandwidth, I need more of the storage capacity. So it can be dynamically provisioned. It can be given at runtime. So how you will define it? A complex network server computing environment where server computing instances are provisioned or deployed from an administrative console or client application by the server administrator, network administrator, or any other enabled user. Means you can dynamically provide the resource at the time of requirement. Now, multi-tenant design. Tenant means a person who lives on rent. So here multi-tenant means that a single instance of the software is made available to multiple clients, and that software or that application or that resource is available on a server. So a single resource is made available in the form of instances to multiple users or multiple clients. With a multi-tenant architecture, a software application is designed to virtually partition its data and configuration. Thus, each client organization works with a customized virtual application instance. For example, you are using WhatsApp, probably all of you are using that. Or if we talk about Facebook, you all are using Facebook. These are the examples of how actually cloud provides a multi-tenant model. You are using your emails. Gmail gives a 15 GB space, and everyone can have their email IDs on Google Mail. Now, how it is actually a multi-tenant architecture? Gmail is one application or Facebook is one application, but every user is getting an instance of that application according to his or her requirement. For example, somebody is using Facebook as as an application to actually use commercial or to use it in a commercial way to advertise their product. Somebody else is using to just meet with their friends online, to talk to them, to post their photographs, and that's it. So it is a multi-tenant architecture where every user can customize it according to their requirement. And what are the client oriented requirements are customization. Every user can customize it. If I want to use it as a commercial, suppose I want to use Facebook as a commercial package, I can do it. It will give me certain features so that I can use to promote my say product. Similarly, somebody only needs it to get uh, say they can talk to their friends, they can talk to their relatives because they're living apart from each other, they are living in different locations. They can use Facebook for that also, and then it gives you quality of service based on how the security and robustness is achieved. Then we have availability and reliability. Availability means the uptime up to which the system is made available, and reliability means how the system is reliable enough so that in case of faults, your data or your important information might not get lost. So these properties are achieved by using fault tolerant system, system resilience, and system security. What is a fault tolerant system? When a system continues to operate in spite of there is a failure in a component, or there is a possibility that the entire system is not able to function properly. For example, had you ever seen that Google search engine goes down? Probably once it hardly happens in an year or in a month that you ever find Google gets down. But can you imagine how this is possible? When we are using Google, we are actually using some hardware to handle the task, and we are using different software applications to handle and manage all this. We are using crawlers and spiders that are again different type of bots and applications. So there can be a case where the system is not working. There can be a natural calamity. There can be any disaster. Again, how come Google is able to achieve all this without affecting its services? It is by achieving a fault tolerant system. And how it is done? There is no single point of failure. If one node fails, there is a possibility that the content or that the services can be delivered using another node for detection and isolation. If there is a component which is not working properly, it can be detected and can be isolated from the system so that it may or might not affect the rest of the system. And containment. Containment means if there is a problem, that system should be contained. System should be taken into account and will be then checked and diagnosed and accordingly being treated so that the failure should not propagate, and there should be availability of reversion modes. So this helps to achieve fault tolerance nature. Right? So this is something which we had discussed, single point of failure. It will not be that the entire system should stop working. We actually find out where the failure is and we isolate that. We can use different mechanisms like fault detection and isolation, and we can also isolate failing component if we are talking about cloud computing. Right? So fault containment we had seen that if we want to stop the propagation of the failure, we have to find out where the failure is and how we can check that component. Now, system resilience. Resilience is also called failover mechanism. Failover of mechanism means if in case of any failure, the entire system goes down. This will not affect the user experience. And how it is possible? What we can do, there can be many of the risk which prevails. For example, there should be a power loss. There should be there should be a possibility that the database or the software might got corrupt, and there can be a natural calamity as well. So in that case, we have some options. Like we have an option for disaster recovery, where we have certain processes, policies, and procedures which are predefined so that we can prepare for recovery and continuation for technology infrastructure critical to an organization. Right? So we can improve those, or we can have a restoration method. And what are the common strategies? Either we can have a backup of our data so that we can replicate our entire system, or we can have a partial or a semi-partial data replication of the entire system, and that can be offsite on a regular interval. And we can use different methods like local mirroring system, surge protectors, or UPS for that. Another aspect is security issue. Because we are using cloud, that way we are putting our information or data on internet, or we are using internet to store our data on some other machine which we actually don't know where is. So cloud security is an important subdomain of computer security, network security, and information security. And it involves a broad set of policies, technologies, and control. And this is one of the important research concepts because, see, what we actually care about, how secure our data is, how secure our information is. Will it not be get leaked? So this is another important aspect when we talk about cloud computing. And what involves or what are the various issues related to security and privacy, data protection, data as a customer, I don't want my data to be leaked. Then, and I also want that my data should be segregated from other users' data. Similarly, identity management. Uh, there are systems which are called identity management systems, which are being used by organizations because we all know as a single user, I can have multiple email IDs. Means I can have multiple internet identities. So, how we will manage that? How we will control that? So that a right identity will get an access to the information, and so that we do not have a data breach. Application security, because applications are available via cloud, they need to be secure. Privacy, our data should be masked because it is sensitive information, it should not be accessed by unauthorized users. Then manageability and interoperability. When we talk about manageability, it is influenced by network management activities, and it is related to how the things are being managed in terms of users, in terms of services, and in terms of the SLA, service level agreement. Interoperability means how two systems or how two modules or products can be used in context with another, or how they work with other products or systems, and do it needs a restricted access or implementation, or they can easily be integrated, and these are achieved with the help of automation and monitoring. Now, automatic computing means that the system should be capable enough to self-manage, so that it can handle the complexity of the growing systems and it can manage them properly. So that is what autonomic computing is. And we require autonomic components. For example, you would have learned about neural networks. They read from their data, or they analyze with the help of their experience, or robots, or these type of mechanisms. So we need autonomic components which can handle this, right? Then system monitoring. Obviously, if we are using a system, it needs to be managed, it needs to be monitored so that different states of a given user of data can be monitored, can be collected, and can be used. And this can be done with respect to physical and virtual hardware state. You can use resource performance matrix, whether the resource is performing well or not, whether it needs some improvement or not, the patterns with according to which networks can be accessed, and this will help to find any intrusion, whether there is a breach, whether there is a intruder, that can be also monitored, and you can manage the system logs based on whether for example, we are in a college, we are in a university, so we've been given a slot, let's say, of 9 to 5. So system logs will help us to check that is there any user who is accessing the internet before 9 or after 5, and who is he or she. So these all will help us to monitor the things in cloud as well. And then we require a billing system because we are working on the concept of utility computing. So utility computing requires billing to be done. So it is based on a metered service, pay as per use model. The amount, how much you use, the usage will define how much you pay. So it has to be defined by the cloud provider, the list of service usage price. And cloud provider also records the usage of a given service or resource based on every user. For example, you would have seen that Gmail gives you a message that your 15 GB space will exhaust soon. So purchase space or delete some. So what is this? This is how the resource usage is being tracked, and accordingly you've been asked for either to purchase more space or delete some. So that in case if you want more space, you've been charged or billed according to it. And how this is done with the help of monitoring systems. Then we have performance and optimization. Now what performance guarantee? As we are using cloud, cloud gives immeasurable, unlimited amount of resources, and thus it provides a guarantee of performance. So how it is possible? Usually when we talk about cloud, there are vendors which uses commodity hardware, a low price solution, which are very powerful in the sense that it can be used on a rented basis, and they gives you a very powerful infrastructure and underlying resources which are highly performed and which works in a highly optimized environment so that they can deliver quality of services to the users. And this is done with the help of parallel computing, means that the load is being divided parallelly on multiple computers so that not a single computer will get the task to be done, which is need to be load balanced with the help of job schedule. So what is parallel processing? As the name says, for example, if I say find the number of the student in your college who are doing BTech computer science, it will be easy for you because then what you will do, you will find the number of the student in the course for all the semesters, and then you will find the sum of all the values, and you will get the number of students. Now if I'll say find out the number of students who are in BTech CS in all the geo campuses, it could be Bhintal, it could be Halwani, it could be Graphic Era Hill University. Again, it will be easy for you. You will ask and you will find out how many. But let's say if I'll say you have to find out all the students who are doing BTech CS in Uttarakhand region, it will be very difficult for you. Now what you will do, you will ask your different friends from all over Uttarakhand region who are studying in different, say, universities or colleges, and you will collect the data from them. This is what parallel computation is. What you did, you had done the same job, but now you divided the job amongst your friends, and each friend is giving you a count, and based on that, you will find the final value. So, parallel processing can be defined as a form of computation in which calculations are carried out simultaneously. Now, every student is counting by their own. So, that is how parallel processing actually works. They count, they divide the large problem into a smaller one, and then solve it concurrently. And how it can be done, when we talk about computing itself, it can be done using multi-core computers like dual core, quad core. It can be done using symmetric multiprocessors, GPUs, vector processor, using distributed computing in the form of cluster and grid, or using software approaches like parallel programming languages. Then we have load balancing. Now this is required. Why we require it? We need to distribute the workload. Now, if I'll say you have to count the number of students, and there is only one student who will be counting the entire number of the student in Dehradun region, and the rest have to find out, like let's say there are 10 who will be searching in Haridwar, who will be searching in some other region. That means the one who is finding the total count in Dehradun will have the maximum load, and this will reduce the efficiency. So we have to balance the load. So load balancing can be defined as a technique to distribute the workload evenly across either to the computer, to the CPUs, to network links, or any other associated resources. And why we need it? So that we can optimally utilize the resource, so that we can achieve maximum throughput, and we can minimize the response time. Response time means, if I'll say only one student had to collect the data from entire Dehradun region, it will take more time for him to collect the data and to give me the response. So it will minimize the response time and it will avoid overload. So why should we balance? To improve resource utilization, to improve system performance, and to improve energy efficiency. Then we have accessibility and portability. Accessibility means the degree with which a product, a device, a service is accessible, and portability means uh, so that we can access services using any device, anywhere, without any problem. So, talking about cloud computing, these are achieved using uniform access and thin client. And what is uniform access? You probably are using Gmail, using any of the available browser, you're using Gmail app. So this is a uniform access. Means you can use any of the device of your choice, and accordingly that service can be provided to you. And it will not say that you have to install a special software or a special tool in order to access the service. The only concern is that you need to have a proper internet connection. Then we have the concept of thin client. Thin client means, okay, we have Gmail in our systems. Do we need to process the content by who? Do we have to find out that which is a promotional mail, then we have to put it in the promotional tab? No, it is done by the system itself. So thin client is that where the client does not have all the capabilities in their system in terms of CPU, in terms of performance, in terms of computation, rather than all the things are done by the server, and the things will be processed and given to the client. So it's just like a cook food. I need not have to do everything by my own. I'm getting the things done by the server. So this is the concept behind thin client. And why this is important? So that we can have a client hardware which can be cheap, because client cannot purchase everything, and we can have a diversity of devices, because we are accessing the content on mobile phones also, we are accessing the content on our laptops or on desktops or even on our smart TV. So there can be any type of device, so it can be handled properly, and it should be a simple uh, say simple service which can have maximum operational functionality. So based on all these capabilities, all these features, NIST has given 5 essential characteristics of clouds, which says the very first is on-demand self-service, which means the service is available or is being provided if you require it. Broad network access. Any type of network can be used, uh, which can interact with internet, which can then be able to access cloud. Means you can use it via local area network using a Wi-Fi setup, whichever you require. And it should be 24 by 7 available. Resource pooling. You name it and you will get it. Means any type of resource can be made available because the resources are pooled or resources are provided through a shared pool. Rapid elasticity. According to requirement, the resources can be provisioned or deprovisioned. And measure service. You've been metered or you've been charged according to a meter. And this meter is being managed by the vendor. So it's a measure service. Your usage defines the payment. So these are the 5 important or essential characteristics of cloud computing. Now what we can gain from cloud? These are the benefits. It will reduce the initial investment in terms of a market or an enterprise. It will reduce capital expenditure. It will improve industrial specialization and it will improve resource utilization. And how it is possible? This we already had seen because of the various features which cloud exhibits. And in terms of end user, it reduces local computing power, local storage power, and we can use a variety of thin client devices in our daily life. So these are the benefits of cloud. Now in the next session, we will be discussing about the various service models provided by NIST and the various deployment models. Thank you.